Hi everyone. In this tutorial I want to show you how to make geometry from puzzles. At the beginning, I drew a curve like this, which will be the groove for connecting the puzzles. Then I copied it to a new layer and flipped it, getting the second curve in the opposite direction. I also saved the selection endpoints of the curves. Now these selections can be used in procedural operations. In the next step, I created a procedural sphere. In the second step, I created polygons, on which we will place the curves created at the beginning. First I connected the base sphere. And then I added an edge chamfer to expand the edges and get the polygons in place of our edges. And in the end, I deleted all the previous polygons, leaving only the long polygons from the chamfer. I also used area selection to remove small polygons. The second step is over, let's move on to the third. In the third step, I reconnect the base sphere. I then add an edge to curves node to extract one edge as a polyline. You can choose any edge index as long as the polygons are about the same size. Don't forget to switch the type to polylines. Using the curved probe node, I extracted the length of our polyline. In the fourth step, I placed the curves on the positions of the polygons created in the second step. I connected these polygons to the basic particle modifier. And I connected the particle modifier to replication. Now our curves are in the right place for us. In the particle modifier, you need to set the rotation on the x-axis to 90 degrees. Now the curves are directed to the side, not up. These are the curves I created at the beginning. To find out the size of the curve, I used the mesh info node. Then I divided the unit by the size of the curve in the x-axis. And I divided the length of the polyline by 1.2, since our edges are not all the same length. Then I divided the result of the first value by the second and got the desired scale of the curve. If we change the number of segments, the curves will scale according to the length of the edge. In step 5 I cloned the cylinders at the vertex locations of the base sphere. Yes, they are cylinders but very small. I then used the particle clone added in Modo 16.1 v1 to place the cylinders. These cylinders will attract the endpoints of the curves. Then I created a highly poly sphere object from the main sphere. I again connected my base sphere. After that, I increased the number of polygons for the sphere twice using the subdivide node. And smoothed the polygons with the set polygon type node. And at the end, I added a set vertex normals node, which we will need later. In the seventh step, I connected the ends of the curves to each other. I connected a replicator with curves to the merge meshes node. To bind the end vertices, I used the surface constraint node. To which I connected the selection of the endpoints of the curves that I created earlier. And the cylinders to whose positions these vertices will be snapping. Now the ends of the curves are next to each other. I then used the surface constraint again to bind all vertices to the high poly sphere. The curves now follow the shape of a sphere smoothly. The next step is to extrude the curves using the curve sweep node. To which I connected the curves. This way I got the extruded planes of our curves. Now I will show you the settings that I used in the curve sweep node. For the correct direction of extrusion of curves, I used the source of normals of the sphere. Set extrusion type to polygon strips. And set the desired extrusion width. After that I connected the ends of the mesh with a vertex merge node. In the last step, I cut the sphere with puzzle lines. I again connected the sphere and added the polygons with the subdivide node. Before that, I saved the selection of the original edges. Now I'm removing our original edges to cut the puzzle lines in those places. Now you can make a slice using the solid drill node. I connected the extruded polygons to the solid drill node, so I slice out puzzles on the sphere. In the solid drill node, you need to select the type of operation slice. I then save this slice as a selection for later use. I called this selection slice. Just in case I added a vertex merge node in order to connect points that are too close to each other. Then using the edge chamfer node, I expanded the slice, to which I connected the previously saved slice edge selection. It is necessary to set a small distance so that the gap is not too large between the puzzles. And with the delete node, I deleted these polygons, separating our puzzles from each other. To align the shape to the sphere, I used the surface constraint node and connected a sphere to it. Then with the thicken node I added thickness to the puzzles. In order for the puzzles to be even on the render, I transfer the vertex normal from the sphere. In the sixth step, we created a vertex normal for the sphere. Since the sphere has a smooth shape, we can use its normal to align the puzzles. With the transfer vertex normal map node, we can transfer the normal from the sphere. Connect our sphere. Select the normal map of the sphere and the type of map. Let's check it on the render. Now the puzzle mesh looks whole and smooth. To destroy the puzzles, I selected them and copied them to a new layer. By right-clicking, I selected Unmerge Mesh to split the puzzles into elements. Now the puzzles are separated from each other. To align the centers, I selected all the puzzles and used the Set Center command. Now the center is in the middle of the puzzle. Then I connected all the puzzles to the Item Influence Deformer. I will delete these puzzles as I already have others. Here is this deformer. I connected a locator to it and set the position along the x-axis to 6 meters. I also used falloff to control the destruction range. Then I connected all the puzzles into one object to add random rotation with a jitter node. Let's see how the puzzles are destroyed. I think it looks great. You can see how the jitter node rotates puzzles randomly. You can purchase these modifier channels on my Gumroad. How they work I explained in my growth modifiers video. Using them I animated the parameter values. Let's see how it looks on the render. Now if we change the segments of our base sphere we get more puzzles. The more segments, the longer the processing time of procedural operations. Thank you for watching. I hope you liked it and maybe you learned something new.